Hey guys, we're going to look at some free response questions here. So question number 12 in chapter 7 states, here's the histograms of the values taken of the resamples in several hundred samples of the same population, and the true value of the population parameter is marked below. So we see this is where the truth is. So this kind of makes us think of Beyonce. And we notice that this looks a little skewed. So maybe N, if this was a sample mean question, maybe N is something smaller than 30, like maybe 20. Here, maybe this one is 30. It looks relatively symmetrical, relatively bell-shaped. Notice here it's symmetrical and bell-shaped, and it's much narrower. So we know as N increases, then it gets narrower and narrower. The variability decreases. So it says, which statistic would provide the best estimate of the parameter? So our answer would be definitely A is best, because it is symmetrical about the arrow, right? And we know what the arrow means. The arrow is the true value of the population parameter. Symmetrical about the true value of the population parameter. And it would be a more accurate estimate because the variability is very small. And variability is small, or smaller than the other ones in comparison. Now we look at question number 713. It states, the amount of the household pays service providers for access to the internet varies quite a bit, but the mean monthly fee is $50 and the standard deviation is 20. The distribution is not normal. Okay, so this is a problem if and only if our sample sizes are small. But we notice here that the sample sizes are not small. So we know that even if the distribution is not normal, that the sampling distributions would be normal when N is greater than or equal to 30. So it says, even though the distribution is not normal, many of the households pay low rate as part of a bundle with a phone or television, but some pay much more for internet only or for a faster connection. A sample survey of an SRS of 50 with internet, how much they pay. Let X be the mean amount paid. So if they're asking us the probability, explain why you can't determine the probability that the amount of a randomly selected household exceeds 55. All right, so if the mean is 50 and they want me to figure out the area under the curve this way, then why can I not determine that out of not a sample, but just a randomly selected? This is a sample from the population. I can't use norm CDF because the population distribution is not. So maybe this is skewed right. So therefore using, or that's, yeah, skewed right. We can, so for A, I can't use norm CDF because to calculate probability of something from the population, because the population distribution is not normal. Now, this won't stop us from making some type of probability calculation off of the sample. But if I'm pulling from the population, I can't. What are the mean and the standard deviation of the sampling distribution? Okay, that we can do, 7.13b. That's what we learned, right? We learned that mu x bar is equal to mu, and they told us that that's on average, they pay $50, right? And what would this be? We know it's that divided by the square root of n. So we know that it's 20 divided by the square root of 50. So we get about that? That would be our variability, right? Now, it says, what is the shape of the sampling distribution? Lord have mercy, they've asked this all day, every day. The shape of the sampling distribution is approximately normal, right? Because the central limit theorem states that n greater than or equal to 30. And here n is, what was our sample size? 50. So 50 is greater than or equal to 30. Now there's some other stuff in the book that we didn't dig into that we'll get into a little bit later, but it's also this like 10% condition that we do with the proportion. That has to do with the population. I haven't dug into that yet, so we'll get there. All right, and D, find the probability that the average fee paid by the sample of the household exceeds that. So we can do our calculations, and we're going to do that. Right? That's what we've been practicing. So 7.13D, we can say that it would be norm CDF, lower bound of our sampling distribution would be centered at 50, and this would be, because we have a sample size greater than 30, that would be normal. So our lower bound is 55. Our upper bound is a really big number. Our mean we know from right here is 50. And our standard deviation we know because we calculated it, 2.83. All right, so we need a norm CDF calculator. It's pretty easy to get one of those. We go to Google, right? And we type in norm CDF. And we said that the lower bound was 55, right? And the upper bound was a really big number. And our mean was 50. And our standard deviation was $2.83. And we calculate. And we get 0.0386. I'll round that up to 0.039. All right, another free response question that asks questions in a little different way is about a sample proportion. So it says, according to the government, 22% of Americans, children under the age of 6, live in households with income at the official property level. A study of learning in childhood shows that an SRS of 300 children from one state, and they find their sample is 0.29. Find the probability that at least, so that's 29 or more, at least 29% of the samples are from poverty, assuming that 22 is in fact, right? So if I said bring at least $29, that means bring $29 or more. So that phraseology at least means that or greater. Can we do that? The answer is yes, I hope so. That's what we've been working on, right? So we know that P hat is P, which we know we're supposed to take as that. And 300's big. I'm not going to do my 10% condition, but I know that 0.2 to end. I say I'm not going to do it, and then I always do it. 0.22 times 300 is going to definitely be greater than 10, and 300 times 0.78 is also going to be greater than or equal to 10. You feel me? So this would be 66 people. 66 is greater than 10. and this would be 234. That's definitely greater than or equal to 10. Okay, so we're good to go there. So that means that our sigma, p hat, would be p1 minus p over n, and take the square root of the whole thing. So 22 times 0.78 divided by, my sample size is 300. So we get these two numbers, our mean and our standard deviation. So we can do a norm CDF calculation. My lower bound right here, my upper bound, really big number, my mean, and my standard deviation. Gorgeous. Bingo, bango, bongo. I calculate that, and we get a very low probability. So there is not a chance. That is very rare to get that high of a poverty level rating. That is 7.14a. So 7.14b asks, based on your answer for part A, is there convincing evidence that the percentage of children under 6 in the household with income less than the poverty level is something greater than that? And our answer is yes, we actually do have some convincing evidence here, which normally we don't. So this is telling us there's a 0.0017 probability that more than 29% of the samples are from poverty level households, right? And because that's unlikely, we do have convincing evidence that the percentage of poverty level kids is more than, something more than 22%, because this probability is, this is definitely less than 5%. All right, question number 15. I'm going to have to add in a little bit of my drawing space here. All right, it says in a children's book, the mean word length is 3.7 with a standard deviation of 2.1. In a novel aimed at teenagers, the mean word length is, so we can simp that as a sample, 4.3 with a standard deviation of 2.5. Both distributions of word lengths are unimodal and skewed right. Okay, so something like that. Independent random samples of 35 words are selected from each book. Ah, I see. So these are actually, I'm going to correct this. This is sample 1, sample 2. I see what they're doing here, right? We knew this was coming. We knew we were getting into this 2-sample business. Let XC represent the sample mean from the children's books, XT. So they want to call these C, children's books, T. Novel. Find the mean, A, of this. Well, we know that that should just be mu C minus mu T, because the center should be if this is greater than or equal to 30, and it is. So since in C is greater than or equal to 30 and in T is greater than or equal to 30, then this would be true. My sampling distribution is, it says justify the shape of the sampling distribution as normal. So look at me, I'm just trying to answer question number C already. Since those, then the sampling distribution is going to be approximately normal, even though the other two distributions aren't. All right, so to finish out A, it says, what would mu C be? 3.7, and mu T, 4.3, and that's what we did with our Skittles and M&Ms. We just subtracted the two numbers, and the other example we did as well. So we get, what do we get? Negative 0.6. All right, so for B, it says calculate, interpret the standard deviation, and verify the 10% conditions met. So I haven't been working on this 10% condition, but worked on it a proportion, but I didn't have time to work on it with a means question. There's also a 10% condition, and we go to say that it's safe to assume there's more than like 350 books. And more than 350 books. So I multiply these numbers by 10, and I say it's safe to assume there's more than 350 children's books and textbooks, and like these populations are large enough. Okay. All right, so we did that. Now, calculate and interpret. This is my B. Calculate and interpret the standard deviation. Well, I have two here, right? So the standard deviation of this looks like I'd subtract, but I'm not going to, right? I'm going to take sigma squared over n and sigma squared over n because I can add variances and then take the square root of the whole thing. I have those numbers here and here, go here and here. Here and here, go here and here. I got it. So 2(1) squared over 35 plus 2.5 squared over 35. Take the square root of the whole thing. What do we get? 0.552. All right, calculate and interpret it. What does it mean? Well, it means that if the difference of the sample between the two students should be this, then we assume it would vary by a half of a word, right? Last question, D. I should write something in there like, typical sample would vary by 0.552 words from the mean difference of negative 0.6. Okay, so that's how wide it would be to the left and the right of this number. D says, what's the probability that a sample mean word length is greater in the sample from the children's book? Okay, that's really important. That's actually the question I want to answer. So I have to kind of think here. My center is going to be at negative 0.06, right? And I'm doing children's book takeaway textbook. So it's like, what's the likelihood that the sample mean word length is greater in the children's book? So if the children's book was 5 words, right, mu C, and the textbook, it's like, what's the likelihood that the children's book is greater? Notice I get a positive number if the children's book is greater. So I need to find 0, and I need to find the area under the curve, any number positive of that, okay? Because that's what, if I get a positive number, it means children is greater because they told me to do children minus the novel. Okay? So, no bigs. I'm just going to do norm CDF, lower bound, 0, upper bound, big number, mean, negative 0.6, standard deviation, 0.552. Bada boom, bada bing, I'm going to be done. 0, 1,000. 0, really big number, mean, negative 0.6, 0.552. Calculate. It says 0.1385. And we's done. 0.1385, they asked for the probability, and I've given it to them. About 14% of the time, the children's book would actually be longer for an average word count. That's what that number means.